Never fear, spiritual microwave is here, and I realized I forgot the G. Anyways, understanding viral mutation transmission, a practical guide to how viruses evolve and spread. Hopefully, a clear explanation of the science behind transmission, mutation, vaccine efficiency, and herd immunity, designed for anyone who wants to understand what's actually happening with the hantavirus right now. The first parts, I'm going to kind of use COVID. The second parts, I'm going to use the hantavirus. So just, and if you think anything's wrong or like you work in the field, like epidemiologists and stuff, let me know. Also, I do have a tongue tie, so like that word, I just tried to not slaughter. I can't pronounce correctly, even if I tried, because I have a tongue tie. So keep that in mind for this video. If you're watching on TikTok, this will be in parts. If you're watching on YouTube, it's one long video. Let's get into it. So how viral mutations actually happen. So a virus doesn't just sit down at the kitchen table one day and decide, I'm going to mutate today. No, mutations happen because a virus's replication machinery makes random mistakes. So think of it like photocopying a photocopy of a photocopy. Eventually things change, and I just realized I could have used a telephone game analogy when I was failing to come up with one for this section. I'm so sorry. I had to make it complicated. And I told you it was going to be a clear explanation. I apparently lied. I'm so sorry. Anyways, there are 3 ways a virus changes. First is the random copying errors, aka natural drift. So every time a virus copies itself inside of the host cell, there's a tiny chance for a mistake. So for RNA viruses like the hantavirus, the error rate is higher than DNA viruses because their copying enzyme is sloppier. Most mistakes make the virus weaker. Occasionally there may be one that makes it stronger. Then we have selection, pressure, evolution. So the mutation makes a virus spread better, right? That strain then replicates faster and becomes more common in the general population it started in. So if a mutation makes it weaker, it dies out. This is like literal, actual, natural selection happening in real time that we can see, you guys, and track and measure. And the virus with the better mutation outcompetes the others, just like natural selection, looking back. Okay. Then you have vaccine immune response pressure, right? So when most of a population is vaccinated or immune, aka they've been exposed to the virus, beat it, whatever, have some sort of immunity to it, the virus can only infect people whose immune system it can effectively evade. So variants that escape the antibodies, they survive, okay? And then they continue on their journey. Variants that don't get eliminated. This is why we see escape variants. Not because the virus is trying to like literally escape, but because only escape-capable variants, escape-capable meaning it evades, right, past the immune system and infects its host, those variants survive to then reproduce and keep reproducing. Why does this matter? Because mutations aren't rare. You think because of the word mutation it'd be rare, right? Not in this scenario, not with viruses. So they are not rare. They actually happen constantly. The question is, which mutations will persist? The answer is the ones that help the virus spread in the current environment it's in better. Okay, so what actually makes a virus more transmittable? So there are specific measurable changes that make a virus spread faster, and these are not mysteries to epidemiologists. They can predict them, you guys, which is really cool. You should look into the science behind it if you're a science nerd. So the key mutations that increase transmission, we're going to talk about them. Better cell entry, aka receptor binding. So what is it? The virus's surface proteins bind tighter to human cells, like a lock fitting more snugly in a keyhole, right? So let's take one of those old style skeleton keys and like the keyhole you'd put it in, right? There's a little bit of room to wiggle it, right? Now imagine that you had the key and it opened the door you were trying to open, but you had to like give it some pressure because it fit really snug. That's the analogy I'm trying to make here. Mutations that improve this binding allow the virus to infect cells more efficiently. What happens? Well, the virus needs fewer viral particles to establish the infection in the host. So more cells are going to get affected per exposure. Transmission increases. A real example is a Delta variant had mutations that increase receptor binding twofold compared to the original virus. Now you have immune evasion. What is that, right? Well, mutations that change the surface protein so the antibodies to someone who's maybe already been infected by it and beat it and has some immunity, well, it's changing its surface protein so the antibodies don't recognize the virus as effectively anymore. So what happens? Vaccinated or previously infected people become vulnerable once again. The virus spreads through populations with existing immunity, and I will explain herd immunity a little bit down in the video. A real example is Omicron could have infected many people who had been vaccinated against the Delta strain. And I think Omicron was the first strain I actually got of COVID, and in the hospital because I had, as the nurse quotes, the most impressive looking hives covering head to toe inside and outwards. I don't suggest that journey. And then I battled with constant anaphylactic-like reactions for like 6 months after. Anyways, I had to get all my vaccines again, which makes me want to pause. So when that was all happening, I had to go to an infectious disease doctor, and he told me that actually a lot of adults need to re-get their vaccines from childhood. So keep that in mind. And if you're anti-vax, there's no use in trying to argue in the comments, okay? Y'all are not smart. And no, I did not get vaccinated for COVID because turns out I should have known I might have had a weird reaction to COVID, because when I tried to get the vaccination because I needed it for work, it was like mandatory. It was a whole thing. And I needed the job. Anyways, essential worker and all. I broke out in hives and had to have an EpiPen because I couldn't breathe. Yeah. So there's actual reasons why some people can't get vaccinations. Like, I will never be able to get the COVID vaccine unless my body decides to calm down. I know it's not mast cell involvement like they originally thought. We don't know why. What is happening? So that's a whole other story. But moving on. So you have higher viral load shedding. So what is that? So mutations that cause infected people to produce more virus particles, especially in like respiratory secretions. Think spit, saliva. Think you sneeze and that kind of thing. But what happens? Infected people release more virus when they cough, sneeze, or talk. Transmission becomes more efficient even without close contact. So the hantavirus is a very close contact for prolonged exposure. And if it were to mutate, this is how it could then be more transmittable to the general public. But we will get into the hantavirus, so don't like freak out and be like, oh my god, she's saying no, I'm not. Sit down. We're not done. We're far from done, actually. You can't see my little progress bar up here. Anyways, why does this matter? This is the difference between needs sustained contact and spreads in casual encounter. So the hantavirus is currently classified, the certain strain is classified right now as needs sustained contact. And, well, like COVID is spreads in casual encounter. That's the difference. So the longer infectious period. So what is it? Mutations that allow the virus to persist longer in the host body, right? What happens? Infected people can transmit the virus for longer. They're infectious for 7 days instead of only 5 days. More opportunities to spread the virals. Okay? From everywhere. Here. Comes with these two specifically. But here's the critical understanding. So all of these are measurable, you guys. We can sequence the genome. We can see the exact mutations and predict transmission changes. This is how epidemiologists identify variants of concern before they even become a problem. And you're about to probably say, then why didn't they see that with COVID? Look up the research. Okay, we're back. So applying this to the hantavirus, okay? So it is a unique virus that can transmit from human to human, while other hantaviruses can only transfer from rodent to human. But here are the current statistics I was able to pull. Let me know if I'm wrong on any of them. So you can kind of see the statistics here. Now, we're going to go to scenarios. What would make it more transmittable? So we have scenario A, the better human cell binding. So basically, it would change its surface proteins of the Andes virus to bind to human receptors better, specifically the PCDH1 receptors. So the mutations that increase this binding affinity would allow the virus to infect cells more easily. The expected outcome would be same transmission route, respiratory, right? But higher probability of infection per exposure. And then we can detect that, though, with the genome sequencing, which is not back yet for the one that was on the cruise ship. I have been looking like every hour, I swear to God. I need to see the sequencing and what it is, because I know we're all kind of freaking out like, hey, is it another COVID? And we won't know until that is back. Just so you're aware. Anyway, scenario B, increased respiratory shedding. So when they cause, like a mutation causes the virus to replicate more in the upper respiratory, so not just in the lungs, like all of it, it would increase it, especially the more viral particles released when you're breathing, talking, in normal conversation, staying in front of somebody. The expected outcome would be transmission becomes efficient even without sustained close contact. It spreads in casual encounters, a higher secondary attack rate, and again, we would detect it also with viral, that's a big word, I'm not going to try to pronounce my tongue tie. Anyways, higher viral loads in saliva respiratory secretions during early infection. You know, someday I will have enough money for that surgery, and someday I'll be able to pronounce words normally, and I am so excited that one day will eventually happen in my far future. Because it's like $15,000. Anyways, scenario C, immune evasion. So the mutations in M proteins that change epitopes recognized by antibodies. Infected people already immune to the baseline antis could get then reinfected with the new variant, similar to COVID. The expected outcome would be breakthrough infections even in vaccinated populations if the vaccines were available, which they are not for this. A larger attack rate. So this is how we would detect it. The genome would show specific mutations in the N protein epitopes, and lab testing shows reduced neutralization by prior infection antibodies. Again, we can test it. Scenario D, extended infectious period. So mutations in the NS's protein that block immune response more effectively. Virus persists then longer in the host. The expected outcome with people infectious for 8 to 10 weeks instead of 2 to 4 weeks. So more opportunities for transmission even if they stopped showing symptoms or never showed symptoms to begin with. And this is how we detect it. So serial case data shows longer intervals between infection and recoveries. Viral load persists longer in serial testing. Now we're going to get into the worst cases, okay? The worst case, convergent mutations. If the same beneficial mutations appear independently in different transmission chains, that's a strong signal the virus is being selected for enhanced transmission. We watch for this by sequencing multiple cases and checking if mutations are identical, like same genetic background, or convergent, different genetic backgrounds. But the reality check is a truly significant enhancement would require multiple simultaneous, oh my god, mutations. I'll leave my mistakes in my video because I'm a real person, and I'm not editing that out. Anyways. It's unlikely, you guys, but possible under sustained transmission pressure, like a cruise ship with 150 plus people in close quarters. That's why I bring this specific route up right here. So how do vaccines work against mutating viruses? So this is where a lot of misinformation gets spread about vaccines and viruses alike. Because let's be clear about what vaccines actually do as the viruses mutate. So, I just realized how badly that cut off. That's frustrating. Anyways, ignore, I guess, the very right column. I don't know what happened to my HTML script because it viewed just fine for me. Anyway, the scenario is it's the same variant that they were vaccinated for, right? Same as the vaccine. The vaccine efficiency, 85 to 95% chance you're not going to get it, right? You said the tiny little chance. Now, if it's a similar variant with only minor mutations, it does go down, but not by too much. Now, a divergent variant, major immune evasion, it goes down even further. Then completely novel virus, aka no prior exposure, it's a completely different variant, etc., 0%. So what vaccine escape actually means in real plausible terms for you guys. So a variant that escapes, in a sense, the vaccine can infest vaccinated people, but can escape doesn't mean complete failure. It means this: primary infection rate, so more vaccinated people are getting infected. Breakthrough infections now increase, but severity is usually preserved. Vaccine-primed immune systems still mount a rapid response, so symptoms are typically milder. Hospitalization rates are going to stay lower as well. So the hantavirus complication, there's no vaccine. It doesn't exist. Not yet. So this is the critical part. There is no approved vaccine for this. So we cannot rely on vaccine-primed immunity to slow transmission. The only immunity is in a population is from prior infection, and that's going to be rare. Why? Well, they're uncommon. They're not an epidemic everywhere. Most people have never been exposed, and high mortality means survivors are going to be rare for this virus. So this is why I flagged it as this is why it's concerning. There's no vaccinated population protecting others through herd immunity, you guys. So every infected person is a potential transmitter without any immunological barriers in exposed populations. It's a mess. Anyways, but let's understand herd immunity real quick. So herd immunity sounds simple. If enough people are immune, the virus can't spread, but the actual math is more nuanced, and it matters for understanding what happens with variants, you guys. So let's talk about the herd threshold and how it's calculated. Here is the calculation for it. I told you we get to the R scale. So we have R0 equals 1. So 0% immunity is needed. So the virus dies out naturally. Then we have R0 equals 1.5. And then that's the 33% immunity needed. Then we have the R0 equals 2.0, 50% immunity is needed. And then at the 3.0, you have the 67 immunity needed. So the current antivirus situation, it is 1 to 1.5. So we are right in there, right? Right? For human-to-human transmission, at least. So this means the virus spreads but slowly. One infected person infects roughly 1 to 1.5 others on average. Containable with isolation and contact tracing, which is what they are doing after the people got the cruise ship before the first passenger even died and showed symptoms. They are working on that. So after 4 to 5 transmission chains, the outbreak grows exponentially, but still manageable if it's caught early like they are trying to do. But that increases to 2.5 or higher. Let's go back up to the scale. The herd immunity threshold jumps to 60%. Outbreak becomes harder to control without large-scale vaccinations or, again, lockdown restrictions like we have with COVID. So what breaks herd immunity? The variants. Scenario: immune escape variant. So the original Andes, 30% population has immunity from prior infection. Herd immunity equals 0%, right? So it's too low to maintain. The virus is rare. This means the virus is rare, which right now, before this cruise ship, it was considered rare. Now say there's a new variant. Okay, this is a scenario. This is not happening. This is a scenario. It is fake. It is made up. Let's say 50% immune evasion now. That 30% immunity now only counts as 15% effective immunity. So it increases from basically 1.0 to 2.0 simultaneously. The threshold becomes 50%. The result of that is viruses can spread again in previously immune people. Outbreak restarts even though 30% were immune. So what to watch for? Here's what you can actively watch for. Cases in people who had prior Andes infections or cases appearing in vaccinated people if the vaccine ever becomes available. I don't know if I trust it. I'm not an anti-vaxxer. I get vaccinated, but I don't know. I don't know about this one. It's such a complex virus. I don't know. I don't think this is when you should rush a vaccine on. If we don't have one already, we shouldn't be rushing one. That's just my opinion, based on science. Anyways, this would indicate, though, immune escape. So we're going to get into the next part 3, about this. We're back. So realistic escalation scenarios. I'm not trying to fearmonger here. So let's talk about what could actually happen. I'm not trying to speculate here, but I'm trying to ground it in the science. So scenario 1, the contained outbreak, which is the most likely scenario off this cruise ship. Okay? So the passengers disembark and return to their 12 countries, right? Contact tracing identifies secondary exposures. Most show no symptoms. That's week 1 to 2. Week 3 to 6, additional confirmed cases appear in direct contact, aka household or healthcare. And serial intervals show 7 to 10 days between cases, which is the baseline Andes pattern. Case count reaches 15 to 25 total globally. Now, week 7 to 12, no new secondary chains identified. All cases are traceable to known exposures. Outbreak is containable. WHO risk remains low. Now, the outcome is the cruise ship outbreak is a contained outbreak. 20 to 40 confirmed cases globally, 3 to 8 deaths. Case closed by June 2026, which is what the outcome I'm hoping for. Okay, because if you have not looked up what this virus can do to you, I highly suggest you do. So this is why it's the most likely. So Andes is low. It's low. The R0 scale is low. Okay? It's low. So transmission requires sustained close contact. People self-isolates once symptomatic. Contact tracing works at this scale we are currently knowing it's at. Scenario 2. Moderate escalation, which is very much less likely but is still possible. Weeks 1 to 4. Same as scenario 1, cases appear in direct contacts. Weeks 5 to 8, though, the secondary cases emerge. Someone who is exposed to a Hondius passenger infects their family member or coworker who infects another person. Contact tracing becomes harder at this stage. Then you have week 9 to 16, geographic clusters form, like Spain, Netherlands, USA, report 2 to 3 independent chains per country. So the transmission then shows characteristics of enhanced person-to-person spread, aka shorter serial intervals, more secondary chains. A lot of words, I know. The outcome is 100 to 300 confirmed cases globally, 15 to 40 deaths, WHO elevates risk to moderate. Genome sequencing shows mutations consistent with increased transmission. Enhanced surveillance protocols activated in high-risk countries. What would trigger that? This. break it down. Scenario 3. Moving on. I'm going to kind of skip through a lot of the bottom parts. I'm just going to have you guys pause and read it just because this video is a lot already. I'm already going to be at like 30 minutes. Scenario 3 is the significant pandemic potential. It's very unlikely, but it's not impossible, and that is why I bring this scenario. If it was an impossible scenario, it would not even be on this list, but because it is possible, even a tiny % chance, I need to mention it. Week 1 to 8, same escalation as scenario 2, but with accelerating secondary chains. So weeks 9 to 16, clusters in 8+ countries, and then it gets bumped up to 2.0 to 3.0, so doubling of its baseline. Multiple independent transmission chains, impossible to trace all exposures. At this point, you can't trace it. You can't quarantine people. It doesn't work at this stage. We saw it with COVID. So weeks 16 through 24, healthcare systems in affected countries become very strained, just like we saw during COVID. Case fatality rate is 35%, creates the pressure of it. Asymptomatic or pre-symptomatic transmission documented through this stage at weeks 16 through 24. Breakthrough infections in previously infected people would be seen around this time too. But again, it's such a rare virus with not very many survivors. Okay, so, but I have to put it in there for science. Weeks 24 onward, global spreads to 20+ countries, thousands of confirmed cases, hundreds of deaths. WHO declares ongoing global health threat. Rapid vaccine development usually is initiated at this stage. If we are able to. If. So if you want to know what would have to happen for it to become a pandemic, pause and read. I didn't type all these words into an HTML document for nothing. Anyways. What to actually watch for. The early warning signs. So if you're tracking this outbreak like I am, there are metrics that do matter here, and these are not me speculating anything. They're measurable, real indicators. Signal 1 is serial interval data. And so I'll kind of go over this. So what to measure is the days between symptoms onset in index case and secondary case. For baseline Andes, that's typically 7 to 10 days. What signals the danger? Okay, we're talking 3 to 5 days consistently instead of 7 to 10. It shows that it's transmitting way more rapidly. Signal 2 is unknown exposure cases. What to measure? Percentage of confirmed cases with no link to the known chain. So basically, there's a percentage of confirmed cases of those people, and the people who they more likely got it from had no contact with the ship that were originated. Now, what signals danger is if, well, the orphan cases, honestly. So the people who got sick but no one can link them to the outbreak transmission is happening in ways that we don't understand. This usually means community spread, not just contact chains. Then we have signal 3. What to measure? The complete genome sequencing for multiple cases compared to baseline Andes and to each other. What signals danger? We kind of already talked about convergent mutations. And we have cluster of mutations. And you have mutations in an unexpected region. Pause to read. Anyways, signal 4. The pre-symptomatic transmission. What to measure? Cases where secondary infection occurs before index case developed the symptoms, okay? Or during the incubation period. What signals in danger? Baseline Andes shows no documented pre-symptomatic transmission. So if cases appear with no other explanation, transmission mechanism is changing. Virus is shedding before immune response even kicks in the person. Signal 5 is the breakthrough reinfection. So people who previously survived this virus. Okay, again, this may be very few. But they're getting infected with the outbreak strain again. And what signals danger is the prior infection provides robust immunity to reinfection. If survivors of baseline Andes are getting infected with this strain, right, from the ship, it has officially escaped the immune system. Major escalation. So current status as of May 9th. Like I said, we're still processing the virus that was on the ship. So once that is released and the statement is put out, I can do an update video if you guys are interested. So let's talk about why this is getting cut off so badly. What did I do? Okay. I will worry about fixing my HTML document later before I'm making a website with all my series I do, and like these HTMLs will be available for you to download and view. I know if you have a Samsung, your phone has an HTML viewer. That's what I'm recording on, is a screen recording it off my Android. But I'm sure iPhone has it too. Anyways, the vaccine and unvaccinated question as it relates to this is what we're going to talk about next in part 4. Okay, so back to this, and hello, welcome back. For the hantavirus specifically, this conversation is different than with COVID because there is no approved vaccine. So if a vaccine were available for this virus tomorrow, hypothetically, if researchers fast-tracked a vaccine for it, same as COVID, basically, you know, the statistics at least. Yeah. I'm like looking at this and I'm like, I really need them to get done sequencing so I can know the results, so I can calm myself down. Because yeah, COVID, whatever, right? Like now it's more milder symptoms. It kind of sucked at first, but this is a whole new ballgame of a virus. And I wanted to make this video originally just to maybe calm people. And honestly, with my research, I am more worried about mutation. And I don't know why. But my brain is doing its brain things. It's warning lights. Which it did with COVID. Anyways. So then you have the population immunity gap. So the current reality is no one in the global population has vaccine-induced immunity to Andes. So some people may have the prior infection immunity. We've already been over that. So this is why it's concerning. There's just no pre-existing population immunity protecting us. None. Not even a vaccine. But what actually matters? So it's actually, this debate's irrelevant to this outbreak, which is why I'm not spending much time on it, but I did include it just to be thorough. What matters is the contact tracing. Right now, it's supposed to be working because it's low. Isolation breaks chains. The biosafety protocol. So healthcare workers definitely need the PPE, the N95, eye protection gloves. It prevents transmission, okay, outside of the hospital room. You have the genetic surveillance. Sequencing tells us that the virus is changing, which we still don't know, and that's what makes me nervous. I need you guys to hurry up and sequence it faster, if possible. Please. Anyways, population awareness. People with respiratory symptoms seek testing. Don't just dismiss it as the flu. Okay, same thing with COVID. If you had a sniffle, go get tested. That's what they were doing. They were trying to track the virus and how it was mutating during the very start of the pandemic. Okay, get tested. That's all I'm saying. So the bottom line is what you need to kind of know right now is this is what we know for certain. You can pause to read. Because right now we have 8 confirmed probable cases, 3 deaths caused by this virus. It has it's low transferring from human to human, okay? 2 to 5% of cases. And the contact tracing, from what I'm understanding and researching, is currently working, so there's no evidence of explosive community spread right now. And the genome sequencing is underway. So results of that are going to show us if the virus has mutations that increases its transmission rates. Because that is possible. It could be possible that the patient 0 on board that ship that died, right? It's somehow mutated to the next passenger, etc. We won't know. So what we need to know is if it's identical to the baseline Andes or not. So that's our biggest thing that we do not have answers for right now. And are there any secondary transmission chains we have not detected yet? That's the next piece. Then will serial intervals show acceleration pattern, or are they going to stay baseline? So they're already at baseline Andes. Are they going to stay there? Or if they're above the baseline, are they going to stay at where they moved to, or are they going to keep climbing? That's what I mean by that. And are there any orphan cases, like I explained earlier, the unexplained exposure? Are they emerging anywhere? So the timeline that really matters. Now through May 16th, the genome sequencing results should be released. May 16th through June 1st, the incubation window closes for April 24th, those who got off the ship. No new symptom onsets equals outbreak contained. Okay, it's contained. It's contained. It's contained better than Jurassic Park. Okay? Don't argue me. Now, June 1st onwards, if all cases stay within known chains and no new orphan cases, outbreak is officially considered controlled. If secondary chains still appearing, escalation may still be possible. So what determines a pandemic? Are the mutations present? Plus, what is the transmission chain pattern? How's it changing? And if both show baseline antes characteristics, this is a contained outbreak. If it shows escalations, well, we're going to scenario 2 or 3. So we're going to go over 3 stories now. And I'm going to let your blanket turn back on because it's getting a little bit cold in here. Anyways, so how does it actually play out? I'm going to do real life scenarios, kind of like role playing, but they're fake names that people give me. Okay? My friends gave me these names. So here's what these 3 scenarios look like in real time with real people, real decisions, and real consequences, but all made up. Like, this is how it would happen, like how it could happen. Like, that part's real, like, but like everything else is fake. Anyways. The contained outbreak, which is the most likely scenario. So, May 1st to 2nd, we have Dr. Sarah, right, at the CDC, receives notification of confirmed hantavirus, on the cruise ship. Initial case count is 5. She pulls up the passenger manifest, 175 people from 23 countries. Her first thought would be, this is contained if we move fast enough. May 3rd to the 8th, contact tracing begins. Ship doctor, ship guide, 3 passengers, all exposed to Leo before he died. Sarah maps exposure window. Leo was most contagious April 7th through 10th. Okay? Which was a week after exposure. So we're using the actual guy who is technically patient 0 in this scenarios. The serial interval is 9 days. Secondary cases appear in schedule. April 16th, the ship doctor. April 18th, the guide. April 20th, the passenger. No surprises there. It's following his baseline. Now, May 10th to the 15th, genome sequencing comes back. Dr. Marcus at the virology lab emails Sarah. No significant differences from baseline antes isolates. Standard drift only. 2-point mutations, both synonymous. They don't change the protein structure. Sarah takes a deep breath out because this is baseline. This is what they wanted to hear. May 16th to 31st, ship passengers who got off on April 24th are now past incubation window, the 8 weeks maximum. Secondary cases in households are still appearing, but they're all traceable. Passenger in Spain infects spouse, spouse isolates, no other cases outside of that. Contact tracing shows 12 secondary cases total, all with direct contact history. So no orphan cases, okay? June 1st to the 10th, last incubation window closes. Sarah prepares her summary report, 23 confirmed cases globally, 4 deaths, 2 aboard ship, 2 after disembarking. All cases within known transmission chains, 0 community spread. So it stays at its baseline. Genetic drift only, no escalation signals detected. June 15th, WHO then publishes final outbreak assessment, and then it's contained. In this scenario, the virus is exactly what we thought it was, okay? That outbreak just happened to happen on a cruise ship because of the perfect storm. The cruise ship, the close quarters, the delayed diagnosis, but the virus itself didn't change. So that's epidemiology working, and this is the most likely outcome from the cruise ship. Now, story number 2, the moderate escalation. Less likely, but possible still. May 1st to the 10th, same as scenario as 1. Sarah starts mapping the outbreak, baseline antes, everything looks contained. Now, May 15th, first anomaly, a case in Amsterdam. Okay, Marco, 50 engineer. He was not a direct contact of any of the passengers, but his wife works at a hospital where the hospitalized crew members were treated, right? So did he get exposed to contaminated materials? Healthcare worker to household contact? The exposure is plausible, but harder to trace here, right? Now, May 18th through the 22nd. Secondary case appears in Marco's chain. His daughter is infected, then her roommate. Serial interval 6 days, shorter than expected, baseline 7 to 10. Sarah notices this. So she emails, okay, Dr. Marcus, we're seeing faster transmission than usual, right? So could mutations be present? So he then checks the sequencing data. Interesting. The M segment shows 3 non-synonymous mutations clustered together. Probably nothing, but let me run comparative analysis. May 24th. Third secondary case in Spain. Person with no known exposure, but genetic analysis shows her virus is nearly identical to Marco's strain, suggesting common ancestor 8 to 10 days ago. Then the phone call from Geneva, a Swiss contact tracer reports a positive case in a person who shared a flight with Marco's daughter. No direct contact, just airplane proximity. May 28th. Marcus calls Sarah. We have convergent mutations, the same 3, right? Changes appear in 3 independent transmission chains with no genetic ancestry link. And now that's considered officially not a natural drift. That's a selection pressure. The virus is becoming more transmittable. And Sarah's blood goes cold. She pulls the data, 34 confirmed cases now, 12 are secondary, person to person to person. So person A, person B, person C. And serial intervals averaging 5.8 days. So now that goes from 1.0 to 1.2 to 1.8 range. June 5th, who would then call an emergency meeting, okay? A moderate escalation. By June 15th, the final count is 127 confirmed cases across 8 countries, 24 deaths. And now they're all stable, right? All the mutations are stable. And who would probably release a statement like, the situation shows evidence of increased transmission compared to historical antes. However, outbreak remains manageable through enhanced surveillance and isolation, and the risk assessment would be moderate. In this scenario, the virus hasn't become a pandemic threat, but it's different from its baseline, right? So selection pressure is evident here. The outbreak is still controllable, but we're entering new territory. So Sarah would publish her data in this scenario. Vaccine development teams would start their work, and this is the scenario where we say we caught it early. Okay? Now, story number 3, the one everyone thinks is going to happen. Okay? Very unlikely, but not impossible. Same as scenario 2, May 1st to the 22nd, anomalies detected, convergent mutations found, but Sarah makes a critical error. All it takes, this is to show that only one person needs to make a critical error, okay? She assumes the hospital exposure is the primary driver, right? Back to scenario 2, got it from his wife, hospital worker who treated one of the crew member. Okay? So she doesn't push hard for asymptomatic testing. She doesn't flag the airplane cases urgently like she should have. By the time the signal is clear, the virus is already in 7 countries through aviation alone. Now, in May 28th, right? Now, Marcus finally gets the full picture, right? He's like, not 3 convergent mutations. There's now 5 of them, okay? And they're not just in the receptor binding domain. They're in the NSs, in the RDRPs, the error rate, aka. And then in the N proteins, the epitope. So this is not a natural drift in this case. This is either engineered or... Anyway, so Marcus calls the supervisor. We need to alert authorities. This looks like the gain of function enhancement. We might be looking at a created variant. June 1st. First pre-symptomatic transmission is now documented. A woman in California infects her husband before she ever showed symptoms. Baseline Andes does not do this. The virus is shedding during incubation. Higher viral loads, suspected serointervals are now averaging 4.2 days. Remember, it's 7 to 10 originally at the baseline. Okay, so now it's jumping from 1.8 at the higher end to 2.3 at the lower end and 3.1 at the higher end. So by June 5th, news breaks the journalist attains leaked WHO assessment, enhanced transmission, Hantavirus. Social media would then ignite. Hospitals would report surge in respiratory cases, panic buying of probably N95 masks and antivirals, and hopefully to God not toilet paper because it's upper respiratory. It's upper respiratory, you guys. Upper respiratory. Okay. But the virus is already in Spain, 45 cases, Netherlands 38, US 67, UK. You get what I'm saying, and it's spreading. This is scenario 3. This is not happening. This is just a scenario. It's a fake. It's how it would happen in real life, but it's fake. All the story is fake. All the numbers are fake, etc. The science is not fake, but the rest is. Anyways, June 12th. Case counts now exceeds 500. Deaths approaching 150. A 72-year-old man in Seattle requires ECMO support. His lungs are failing. Images now circulate. First healthcare worker now dies in Amsterdam, then another in Madrid. Hospitals activate crisis protocols. ICU beds are no longer available. They're just going to be scarce like they were during COVID. If not, honestly, worse. The only thing that might be working in the favor if this did become a pandemic level scale, and I'm sorry to put it this way, is they die faster. And more likely. With this virus. Anyways, June 20th, the breakthrough reinfection confirmed. A woman who survived baseline Andes infection 2019 gets infected with the Hondius strain. Genetic sequencing confirms distinct virus, not reactivation. Okay? So basically, it evaded her entire immune system to what she already was immune from. So the news would then hit all of social media. You can get it twice. Yeah, you can get different variants. Anyways. Or different variants, or a variant with a mutation. Either way. You get what I mean? So June 30th, case counts now over almost 3,000. It's almost 3,000. Deaths are almost 1,000 cases in 23 countries. WHO declares public health emergency of international concern. And the vaccine development team will then shift the 24/7 schedule. Okay? The antiviral trials will begin, especially in those who have a very more than likely bad outlook too, if they did human testing, because it might be the only chance to save them is during these trials. The U.S. announces pandemic response mobilization, but we all know that's not going to happen because of who's in charge. Schools prepare remote learning protocols. and I'm sorry about red states, but yours probably will not. And this is the scenario that nobody wants, especially not now. We do not need a COVID like 7.0, not 2.0, 7. This is so much worse. But in this scenario, basically everything breaks wrong at once. The virus isn't just changed, it's dramatically enhanced. Okay, the mutations enable pre-symptomatic transmission, immune evasion, and possibly higher replication rates. So combine that with the delay in detecting escalation signals, the virus now gets a week of unchecked spread before anyone realizes it's any different, which is what's currently the period we're in now. This is the period we are in now because we do not have the sequencing back yet. Someone tag me if I haven't made a video yet once it comes back. Okay? Please. Anyways. So this guide presents all of these facts as of May 9th, 2026. It's designed to help you understand the mechanisms of viral transmission and mutation, not to predict outcomes though. So the situation with what we got right now will be clarified significantly once it's done sequencing, okay? And once they're available to the public, which again, tag me if I haven't made a video yet and posted it. Anyways, this is built for clear thinking about complex sciences. Let me know. I'm probably going to have to break this down further for you guys, but I hope you guys at least get a grasp of what I'm trying to say here. Yeah. Anyways, happy Mother's Day. And weekend. It's Saturday. And Mother's Day is tomorrow. I don't care. Happy Mother's Day. Okay, we got the Swiss sequencing back. I will do a video on that here shortly with some graphics so you guys understand it better. But we are still waiting on at least 2 more countries to get done with their sequencing to make sure that it hasn't mutated across anybody. But the Swiss one is very promising for scenario 1. Okay, good morning. We're going to talk about the Hantavirus genome, the Swiss patient that's back, okay? So give me a second. I am going to throw it up on the screen in 3, 2, 1. And you're back. Okay, so as you can kind of see, what is this tree, right? I'm going to give you the simple version, okay? So that's a phylogenetic tree. I don't know if I said that right, my tongue tie, but it looks like a family tree, and that's basically what it is. Except instead of tracing your family back to your great-grandparents, it's tracing a virus back to its closest relative. So viruses in human analogies are going to kind of interchange here, okay? So think of it this way. If you have a dog, right, and you ask someone, where's your dog from? Like, I have a dog back in my trunk. I don't know. She likes her hidey hole, so I just, like, accommodate her, but she's a Kelpie Husky mix, right? Right? And if I were to trace her family tree back, and if she had any other DNA out there, like, posted on, like, kind of like 23andMe, like, I'd be able to trace back to what dog she is, but I'd also be able to know what her genetic is. And that's how I know she's Kelpie Husky. So with that being said, in that kind of tree, the phylogenetic tree kind of, like, answers that by showing which other dogs your dog is most closely related to. So they were testing to see how close it was to the baseline Andes, which I went over in the other 5 parts. But how does it work? So scientists took the virus from the Swiss patient, the one case we have the full genome for right now, as of right now. They compared to genetic code to every other Andes virus we have on record, okay? Then they made that tree showing which viruses are most similar to what. Okay, what if you say, well, I don't understand DNA or genetic code, can you explain? I got you. Okay, so DNA is like an instruction manual. So if your body is a house, right, DNA is the blueprint that tells your body how to build itself and work. A virus also has those same instructions. I'm using analogies here, called genetic code. So when scientists sequence a virus, they're reading that instruction manual, you guys, letter by letter. So there are only 4 letters in the viral code, okay? 4 letters in the viral code. A, T, G, and C. And the full Andes virus manual is about 12K letters long, okay? Scientists compare these manuals between different virus samples to see how. Which is where I'm really grateful for how advanced we are with technology nowadays, because can you imagine trying to do that by hand? That must have taken so long. Anyways, so what does, or Hondius, or however you want to say that, it's morning, I'm still only half caffeine gone, so. But what does it show us? So, look at the tree again. Okay, so that Swiss patient's virus, which is labeled right there, sits on a branch with other viruses from Chile and Argentina, earlier historical Andes strains. So the translation is this virus is most closely related to the Andes virus that has been circulating naturally in South America for decades. So it's not a new variant, it's not engineered, and it's a naturally occurring system, right? And this is where I want to tread carefully. because I could say, yeah, we have nothing to worry about, but we don't have the genome sequencing of any of the other patients that test positive. And we need those to just do our due diligence and make sure. Because if we don't, and there is a random mutation that happens, because I explained in my last video, mutations are not, like, rare. They happen all the time, right? RNA viruses, like the Hantavirus, a little bit harder to do. But I would feel safer as a general public if they would please do the rest of the sequencing. So what else does the tree tell us, though? So 3 critical observations I saw is no novel branch. So the virus doesn't branch off in any unusual way. It sits right where we'd expect a naturally circulating Andes virus to sit. There's no sudden mutations that I can see or they found. So if the virus had gained new abilities to spread easier or evade immunity, for example, we'd see genetic changes clustered together, and we don't in this. In the expected genetic distance, so the few mutations that were present are exactly what we'd expect from natural drift over time, aka the virus copying itself imperfectly like a photocopy of a photocopy, or like the game of telephone analogy that I used in my last videos. Alright, so what could have looked scary, but it doesn't? So if it was engineered, okay, let's say someone decided they wanted to be the villain of the entire world, right? And they engineered this. The tree would show a sudden branch breaking away from other Andes viruses. So the virus would sit alone, not clustered with historical strains like it currently does. Multiple mutations would appear together in specific regions, receptor binding or immune evasion, etc. But what we actually see is normal clustering with South American Andes, minor mutations consistent with natural evolution of that virus, and no unusual branching patterns. Genetic code matches historical strains from Chile and Argentina. So if it was a new dangerous variant, like let's say if, it's not, but if, okay, this is purely fictional, okay, we'd see mutations specifically in genes that affect transmission, right? So receptor binding domain, the immune antagonist genes, the viral replication rate genes, the mutations would be specific in meaningful locations, and they are not in this. So what we actually see is the mutations presence are in neutral locations, okay? Not in genes that will change how the virus works. So this is consistent, again, with random genetic drift, not selection pressure. But why does this matter? Let me take a sip real quick. And I'll tell you all about it. So this tree is the answer to a critical question. Is this a naturally occurring virus, or have we discovered something new and dangerous? So it is confirmed natural origin for the switch patient. Engineered variant has been ruled out. Enhanced transmission, very unlikely, but we cannot rule it out yet till we have the other sequencing back. So what this means for the outbreak. So since the genome data supports everything, this is a natural Andes virus outbreak from environmental exposure. It's spreading human to human at baseline rates, aka low, requires close contact. So it's not a pandemic threat right now. The outbreak is currently contained and manageable from science standards, okay? So how do I actually know that this is all true? Well, fair question. Okay, so if you're reading this on my new website once it's up and loaded, or maybe you're listening to my video, well, how do you know scientists aren't lying or making it up? I have verification points. So who published this data? The Swiss National Reference Center for Emerging Viral Infections at Geneva University Hospitals and the Institute of Medical Virology at the University of Zurich. Okay, these are not random people, you guys. They're established research institutions with over decades of credibility at stake here. So this data was posted right there, so you can look it up yourself, which is an open scientific platform where researchers share outbreak data in real time, and any general public person can look up the viruses that are on there. It's peer-reviewed by the global virology community, okay? And I can pronounce a little bit better today, because I took a little bit of So, fun fact, with my tongue tie, it feels like I'm eating glass and pronouncing certain words, but if I take an ibuprofen or Tylenol in the morning, it can sometimes relax the lower bit of my tongue. And I'm doing that for this video because I knew there was going to be a lot of words, okay? Heads up. I'm still going to pronounce things wrong or not correctly because that's just, unfortunately, my medical condition. But, so, what about, where can I see the tree myself, right? So, as I said, go to this website and search for that specific virus, or you can just look up Swiss genome sequencing the Hantavirus, and that's how I found it, actually. That's the Google alert that sent it to me when I was waiting for this. So, and you can see the raw genetic sequence for yourself. You can check the author's credentials. You can verify that data yourself if you want, if you know how to read genetic trees, okay? If scientists were lying, you guys, they wouldn't post the raw data publicly where anyone else can check them. And I know you might say, like, hey, but I don't know anything about viruses or how to, like, read a tree. Well, that's what you got me for, okay? That's why I fact check. That's why I do this. That's why I make these videos. But what about the other cases? Do we have the genomes? No. As of May 10th, we do not. I haven't checked this morning, though. So when they are released, you can expect them to cluster similarly to the Swiss strain because they likely represent the same human-to-human transmission chains from the same source virus, but we'll know for sure once that data drops, okay? So here's some red flags to watch out for. So if someone tells you a scary story, ask, did they cite the actual research? Are they showing you the data? Would this claim hold up basic fact-checking, and are they making predictions without evidence, right? So the bottom line is, this tree tells us that the virus is a naturally occurring baseline Andes. It is not engineered. It is not engineered or artificially modified. It is not a new variant with unexpected properties. It came from environmental exposure in Argentina, not from the ship. It is spreading at baseline rates consistent with known Andes transmission, and the outbreak is currently considered contained and manageable with standard contact tracing. So what we're still waiting for is those other genomes, but based on all the data I have, we expect them to match. Okay, so the real story here is a new pandemic threat. Thank God this is not one you want, okay? Because it literally invades it makes you bleed. It makes you hemorrhage in your lungs and fill up and drown. It's horrible. But you can be informed about this without being panicked. And the data is very clear here, and that's why I'm making this series, okay? Because the virus is baseline. The outbreak is currently considered contained, regardless of American health practice standards. And the tree confirms what we were hoping it would, okay? So this explainer breaks down the real data. And I hope that my website will up and going soon, but I hope I didn't misspell anything or cut anything off. I tried better on this HTML document. But I hope this gives you guys some really good positive answers. And even if the other sequencings are the same or similar, I will still do quick breakdowns for you guys, okay?